Alrighty, guys. So you've probably all played around at some point with PowerPoint or Microsoft Word, and you've gone to the shapes tools, right? Have you guys ever done that before? And there's a lot of kind of strange shape tools on there. For example, there's a shape that looks like this, and you don't have to draw this, guys, but there's one that's like this, right? And it's kind of odd that that would exist. And there's another one that looks sort of like a cylinder on its edge. And there's a kind of a bunch of different shapes of that nature. One that's kind of like a teardrop on the side. Each of those things actually has a role to play in flowcharts. And flowcharts are used by both computer scientists and sort of engineers for sort of engineering solutions to a problem. And each of those shapes has a very specific meaning, okay? We're going to keep it really simple today. We're actually just going to use squares and arrows to represent our Boolean conditionals here today. But I do want you to know that there actually is sort of a set of rules for how you flowchart things so that other engineers or other programmers can read them, okay? So what we're going to do is we're going to do a Boolean flowchart, which means that we're always going to have branches that are true and false. So we're going to represent those with T and F because that's what a Boolean function does, right? If X equals 2, then true, right? Or if X does not equal true or 2, then false or something of that nature, okay? So we're going to actually, I'm going to do the diagrams for the different types of conditionals we did here. So we're going to start with the unary selection, okay? So we have if Z does not equal 8, then print, you didn't type the correct number, right? Because we asked for it to type the number 8, right? And then we just say print Z to see what happens there, okay? So the way we would diagram this out here is as start. So we're just going to represent the beginning of our program just with a dot and a line that comes down, okay? And what we want to do is we want to put a box here with sort of our Boolean conditional. Okay, so I'm going to put a box here. And my conditional is right over here. It is Z if Z does not equal 8. So my conditional is Z does not equal 8. And I have two possible outcomes because this is Boolean. I have true or I have false, okay? In this case, my true statement would give me the statement, hey, you didn't type the correct number, right? If I get a false, then, oh, sorry, no. In this case, if I get a false, we're going to say print, you didn't type the correct number, okay? So the way I draw this out is either it is true and nothing happens and it just runs the rest of the program. So I'm going to use an arrow for that, okay? That's what happens if it's true, okay? If it is false, then what I'm going to have a false line over here. I've got this other thing that can happen. And in this case, it's going to say, hey, not correct, right? You did not put the correct number. So I'm going to write not correct in here. And after it runs that line, it's just going to go right back and continue on with the rest of the program as well, okay? So unary selection, we basically got one little branch that can come off of here, not correct, and then once it tells us that, it runs right back. If it's true, it just keeps running the rest of the program, okay? So that's kind of the flow of work there. For unary selection like that, they're not super interesting looking, but as you get more complex Boolean functions, you're going to see that it's pretty important to keep track of these things. Some of you who have been working on your Choose Your Own Adventure have probably already sort of mapped it out, at least if not on paper in your head a little bit, because as you get things more complex, going to paper is helpful because programming, this is in a linear format, but it's not necessarily running in a linear way, right? It's kind of bouncing around and we have different conditionals in there. Okay, so that's our first one there. That's how we do that. So I'm going to erase this. And let's do the binary version as well. And I'm going to see, is it going to draw or is it going to let me move it? Nope, it's not going to let me move it. I'll use the mouse to do so. Keep it simple. All right, so let's do the binary selection. Okay. Move it up to the top there so you guys can see what we've got. So we asked for an input and we said, hey, type a number between 4 and 8. Okay, so we're going to start our program. And this could be, in our case, because we're writing this all in one sort of screen, this dot would essentially be the end of the arrow for the last program, right? Because that's just the order it's going in, okay? So it's going to come down here and we get to our first selection. We're asking for a number between 4 and 8. Okay, so what I'm going to put in this box is what is my actual Boolean function here, and it's this right here, right? So it's if, I'm going to put it in here, if n is greater than 4 and n is less than 8, we have our true, which is where we're going to say, hey, great job, right? Else, in this case, is our false. We're going to say, nope, you're wrong, okay? So in this one, I'm going to have two options. I'm going to have my true option. So in my box here, I'm going to say good job, because that's what we print out. For my else, which is the false statement, okay, I'm going to have nope, that's not right, okay? And then both of these, regardless of which path we take, is going to just move on with the rest of the program. So we're going to actually bring these back together, and the program continues on, okay? So it doesn't really matter which branch we take. It's not going to halt our program here. And the outcome is only the one we have in the box there. Either we say, hey, great job, or nope, you were wrong, okay? Still not super exciting, but it hopefully is making a little bit of sense. We got our true, we have our false, okay? Now, when we get to nested conditionals, or when these things really come in handy, because most people can keep track of that in their head, no problem, but we want to make sure that as our programs grow in complexity, that we can keep track of where everything's going. Believe it or not, guys, for the teaching staff, using Google Forms, you can build Boolean programs in Google Forms if you give people options to do so. I actually taught the staff how to do it, and I showed them a layout very similar to what we see here that would allow them to keep track of things like that. So you can use Google Forms to actually make a rough Boolean game. It's surprisingly simple to do. So even if you have no programming experience, if you can track where true and false are, you can actually do it. Well, it really is programming, just without using a programming language. You can actually do similar things in Microsoft Excel. And I don't know if you go online, but if you search for Excel games, you will find games online that you can download that operate in Excel. So there are actually Excel-based games out there, including graphics made with colored cells and things like that. So once you know programming, you can start to see where other things that aren't necessarily intended to be programming languages can be used in really similar ways, okay? All right, let's take a look at now nested conditionals and where these things sort of get to be really important. Okay. I really like having that eraser on there. That's cool. I don't have that on my smartboard. All right. Oops, I'm going too far. All right, with our nested conditionals, we're going to have a true statement, and we're going to have a false statement, or else, and then we're going to have another true and false, okay? So if I want to think about this like this, I can say, okay, here's my true statement, here's my false. If I have a false, then I'm going to have another option for true and false. All right, so our program, put our little dot here, draw it down, and let's do our first sort of Boolean expression here. In this case, I said pick any number, right? And in this case, I'm really wanting to know, is it an even number? So I'm going to say G remainder equals 0, okay, for the number I picked. And technically on this one, if I wanted to, I could also say there's an input at that point as well, right? I'm asking for somebody to put some information into here for me. Okay. If I answer true, I have something happen, okay? If it's true here, I'm going to say, hey, that's an even number. Okay, so I'm just going to write here in my little box, even. Okay, if it's false, I'm going to have something else going on. Okay, if it's false, I don't actually say, hey, is it an even or an odd number at this point? I know it's an odd number, but I've got it broken down a little further. I've got another conditional nested in here. So instead of saying false, now it's an odd number, that's not what I'm actually having my program do at this point. I'm having my computer, my program, do a second Boolean assessment here. And in this case, G greater than 100, okay? So again, if my remainder is 0, it's going to say, hey, that's an even number. If it's not, rather than say it's an odd, it's going to now say, is the number greater than 100, okay? If this is true, it's going to say that it is a big odd number, right? Now we get to our odd. And if this is false, it is going to say that this is a little odd number. Okay? So I've got that second conditional in there. All right. Now, if on this original Boolean here, it's true, that program is just going to go and continue running on. Okay? If it's false, it's got to go through this, and then once it assesses that, then it too is just going to go ahead and continue running on as well. Okay? So that's the way we would sort of diagram that particular conditional. And I don't know if you guys remember in biology, it was just a short little one-day thing, but we did dichotomous keys, where you could identify an organism by basically saying, is it this or it this? And if not, go to there. You're actually, a dichotomous key is really a Boolean conditional. And it's a paper version of a program you can carry with you anywhere, right? So, yep, for those of you who remember the dichotomous keys, it's the same deal. And you could actually diagram a dichotomous key exactly the same way as you diagram these. And in the dichotomous key example, they're almost always nested conditionals. But we don't have to do nested conditionals alone because they get sort of clunky, which is the beauty in programming, guys, of the elif statement. The else if allows us to do chain conditionals instead. So does everybody have this? Okay. I'm going to go ahead and erase this. And then we'll do the last one, the chain conditionals. And then you can, do some combination of them as well. You don't have to do purely nested or purely chain conditionals. You can combine all four of these, the unary, the binary, the nested, the chain. You can combine them all together into fairly elaborate examples. Okay, last one is our chain. Oh, I got some true false stuff I need to erase over here. Okay. All right. Now in the chain, it's pretty interesting because what's going to be true and false are going to take us on sort of different paths. But they're all going to eventually converge again as well. But we don't have to do a bunch of branching to get there. Okay. So in our example here, we have put in the variables x0, xy. That's actually totally unimportant right now. We're really trying to look at what we've got. So we're going to ask for some sort of input here. Okay. And our input is asking north, south, east, or west. Okay. Now, our first Boolean we get to is right here. So here's the first thing that we are going to assess. We're looking to see if move equals in, right? That's really what we're doing. So the first thing, we're going to take that input, and our computer is going to say, hey, does move equal in? I'm just going to put the one n in there, okay? Now, if this is true, it's going to print you are moving north, okay? So the true statement in this case, I'm going to move over here. If it's true, we are going to say, hey, we're moving north. If it is false, it's not going to go branching, right? If it's false, it's just going to move down to the next statement, okay? So in this case, false just takes us to our next Boolean, okay? In this case, we're looking if the move is south, right? So if it's not north, now we're going to assess, does move equal south? If that statement is true, then we are going to say, okay, well, we're going south. If you want to include it, then you could basically say for north, y plus 1 is the other thing that's going to be assessed, and y minus 1. But you don't have to include that, okay? So if that statement is also false, then it's going to go down to my next elif statement, or else if. All right, so if this one's false, we're going to now assess, does move equal east, or e? If that's true, we're going east. If it's false, we're going to look to see if we're going west. If that's true, we're going west. And if that's false, we're going to say we don't understand. I don't have enough space to write the word understand, so we'll have to get it there. Okay. All right, so it just keeps chaining down as it goes. Now what our program does then, at any point that goes to that true statement, it's going to bypass all of these others, right? It's not, because we're not going to take the false line at all, the chain, right? So that means then is if it says true here, then this is going to go all the way, I don't really have enough space here, right? All the way down and continue on with the program. If it's true here, it's going to do the same thing. It's going to go all the way down, continue with the program. If it says east, again, same. West, same. If it's false, it's just going to say it doesn't understand, and that's actually going to be considered a true statement, which it goes on. Now, this is actually a loop, right? So it's going to come back and request that input again, okay? And so that's how we can kind of understand the process of that one as well. So there's a lot more kind of going on. I personally prefer the chain to the branching. I think it's a little clearer. It's good for things where there's multiple sort of answers or multiple inputs you're requesting. Like in the case of mine, it's not just a simple yes or no, right? It's a, hey, do you want to go north, south, east, or west? You can do that branching, but I will tell you it'll take you many, many more lines of code to do so, because on each branch, you have to account for the other possible answers that would come in. It gets very complex. So this is a nice way if you've got multiple inputs that you're requesting to handle those. All right. But if you need to put branches in there, you certainly can. There's no rule. Ultimately, I guess the ultimate goal is, that's a bit of redundancy, right? Ultimately, the ultimate goal is to make your code as small as possible. That efficiency, that parsimony is really what we're going with. Okay, flowchart